Okay, welcome to section 2.4. Section 2.4 is basically the same thing as section 2.3, but at the end we try to graph it. One thing to note is that on a test, I don't think you will ever be asked to look at a function, analyze it, and then graph it. You definitely will be asked to look at a function and then analyze it, but not analyze it and then graph it. Maybe like a multiple choice question that's like, what graph could this be? But not like a free response. Nothing like what I'm about to do would be on a test, I guess, is what I'm getting at. But number 1 says, completely analyze and graph the following function. So I'm going to do a couple of things first. So I need to do all of these things, but I'm going to do a couple of them first. So first, I'm going to think domain. The reason I'm thinking domain is as soon as I see a square root of x, my first thought is that's a little bit tougher than normal because I can't plug in negative numbers. I can't plug in any negative numbers, but I can plug in 0 and then any positive number. So that tells me that the domain is from 0 to infinity. And then if you think about what the square root of x looks like, it looks just kind of like that. So again, there's no negative values. It starts at 0 and then goes off to infinity. So it's always increasing. And you can plug in any number, which means it's always getting higher. It's not bounded. So the range is going to be also 0 to infinity. So this actually brings up another question about asymptotes. Neither the square root of x or x squared has asymptotes, so when you put them together, there won't be any. None. So I've done asymptotes, domain and range. I think the next thing to do would be to find the x-intercepts. So this is all like algebra things, which is why I'm doing it first. So square root of x plus x squared. If I want to figure out the x-intercepts, I would set it equal to 0. So I'll do that first, and I will even rewrite it as x to the 1/2. And then I'm going to move the x squared to the other side, so I get negative x squared. And then I could divide everything by x squared. So that gives me, so when I have x to a power divided by x to a power, I can rewrite it using a little bit of subtraction. 1/2 minus 2 is minus 3/2. And that's equal to negative 1. And then I could get rid of the negative 3/2 power by raising it to the 2 over negative 3. And I get x equals negative 1 to the 2 over negative 3 power, which is just 1, I think. So now here's a funny thing. This is really going to test your algebra skills. So I've actually already done this problem, so I kind of know what happens. But x equals 1 is a solution given the steps that we've done, but we need to check that it actually works with our original equation. So let's do that. So square root of 1 plus 1 squared equals 0. Square root of 1 is 1. 1 squared is 1. But 1 plus 1 equals 0, that's false. So what that tells me is I have an extraneous solution, which is kind of surprising. Extraneous solution. So basically this problem is pulling out all the stops on things that you should remember from, algebra. So an extraneous solution means that x equals 1 doesn't actually solve this equation. So I actually have no solutions. And that tells me there are no x-intercepts, except there is one. So right in here, when we divided by x squared, and again, this is really drawing on all the algebra that you did before this class. When we divided by x squared, we were assuming that x was not equal to 0. So, but that might not be true. It's possible x equals 0 is a solution. So I also should check x equals 0. So using a little bit of mental math, the square root of 0 is 0, plus 0 squared is still 0. So it actually turns out that 0 is a solution. So 0, 0 is an x-intercept. Now to find a y-intercept, I would plug in 0, but I actually just did that, right? I plugged in x equals 0 and I got 0. So not only is it an x-intercept, but it's also a y-intercept. And that makes sense because, you know, the y-coordinate here is 0. So I've got a whole bunch of information now. Got domain and range. I've also got all the x-intercepts. And so far, this is just algebra. We've just done some algebra. Let's move on to the calculus part. So I want to start by figuring out where it's increasing, decreasing, or neither. And to do that, I'm going to need a derivative. So let's see. Kind of give myself a space to do that. So to do the derivative, I'll need to remember that the square root of x, that can be the same thing as x to the 1/2 power. So f prime would be 1/2 x to the negative 1/2 power. And then the derivative of x squared is just 2x. And then I'll set that equal to 0. I think I will move the negative 1/2 power down to the denominator. So that would be 1 over 2 x to the 1/2. I bet you can hear my laundry going. I'm sorry about that. And then I'm going to move the 2x to the other side. That'd be negative 2x. And then, let's see. Let's get the 2x to the 1/2 out of the denominator. I'll do that by multiplying 2x to the 1/2 power to both sides. So I get 1 equals negative 4 x to the, let's see, 1 x to the first power times x to the 1/2 power. I'd add the exponents. That's x to the 3/2. And then I would divide by negative 4. So I've got negative 1/4 equals x to the 3/2. To get rid of that exponent, I would raise both sides to the 2/3 power. And that's something let's write that nicely. That would be 2. So writing this nicely, I get negative 1/4 squared and then cube rooted. And that's something I could put into a calculator. When I do that, I get about 0.4. So this is my one and only critical point. So I've got just one critical point. Let's pause and see if we can find a possible inflection point. The reason why I would do that is because I've already got the first derivative here, so it'll be easy to find the second derivative. So my second derivative, using the power rule, that would be 1/2 and then times negative 1/2 x to the negative 1/2 minus 1, and then derivative of 2x is just 2. I can simplify. That's negative 1/4 x to the, let's see, negative 1/2 minus 1, that's negative 3/2 plus 2. That's my second derivative, but I want to find my possible inflection point. So I'll set it equal to 0. and solve. Let's see. I think I would add the 1/4 x to the negative 3/2 to the other side. So that's 2 equals 1/4 x to the negative 3/2. And then I would multiply the 4 to the opposite side just to get all my constants together. So multiplying by 4, I get 8 equals x to the negative 3/2. And I need to get rid of the exponent now, which I can do by raising that to the negative 2/3 power. So, yeah. Now I have 8 raised to the, let's see, 8 squared. Actually, I guess it would be 8 raised to the negative 2/3, which when I put into my calculator is, I actually need to put it into my calculator. When I do that, I get 1/4. That works out nicely. Oh, and it's not approximated, it's exactly 1/4. So this is my possible inflection point. Okay. Now I've got a couple more things I need to do. I would like to figure out where it's increasing and decreasing. So I'll do that by drawing myself a little number line. And I've got 0.4 here, and that's just an approximation, but that's my critical point. So I want to test a point before that, which would be 0. 0 would work. F prime of 0. So I had to scroll up to figure out what my derivative was. That would be 1/2 0 to the negative 1/2 power plus 2 times 0. So actually that gives me kind of a wonky answer. And yeah, now that I think about it, of course it gives me a wonky answer because 0 gives me something sort of weird where I've got 1/2 and then it's 0 on the bottom here. 2 times the square root of 0, and I can't do that, plus 2 times 0. So I actually got to pick something different other than that to plug in. So, and I also knew that even more if I'd really thought about it, because I know that the domain starts at 0. So I really need to pick something between 0 and 0.4. So let's do 0.1. So f prime of 0.1, let's see, f prime of 0.1, that's going to be 1 over 2 times the square root of 0.1, and then plus 2 times 0.1. All right. So I'm pretty confident that's going to be something positive. So the square root of 0.1 is something positive. So I've got 1 over 2 times something positive. All of that is positive. Plus 2 times something positive. So that is going to be something positive. You're totally welcome to plug that into a calculator and work it out for yourself, but I'm pretty confident that's something positive. So now I'll try something on the other side of 0.4, something over here. So I think 1 would work. F prime of 1. Oh, and I'm going to record that it was positive on this interval. F prime of 1 would be 1 over 2 times the square root of 1 plus 2 times 1. And actually, I think that's something positive too. Square root of 1 is 1. 1 over 2 is a half, plus 2 times 1, which is 2. So 2.5, also something positive. So that's pretty cool there. That one thing that tells me is that, I'll try to draw it over here. So I know my function starts at 0 because we found that it was the x and y intercept. So we're thinking that it's positive, and then it's positive some more. So to me, that tells me that there's no max there. So if I don't have a change from negative to positive or positive to negative, that tells me there isn't a relative min. So I know there isn't a relative min there. That's great, or a relative max. So the next question I want to ask myself is, where is it concave up and concave down? So actually I'm going to erase my little picture here. And so concavity question, I need another interval again. So I've got 0 and 1/4 and something past that. So I'll be checking concavity. So let's see. F prime, so actually f double prime of 0.1 would work again. I need to pick something in that interval there. So f double prime of 0.1, and I'm just using this equation up here. So negative 1/4 times 0.1 to the negative 3/2 power plus 2. Okay, so I need to figure out if that's positive or negative. So I'll have to bust out a calculator for that. 0.1, sometimes I can do it in my head, but not this time. 0.1 raised to the negative 3/2 power. And then divided by negative 4, and then I add 2. That is something negative. So I just plugged in my calculator and I got a negative number out. So that tells me it's concave down from 0 to 1/4. Now I need to do the same thing for something in this interval, and it might not be positive, but something in that interval. Kind of hoping it is, otherwise it's going to be kind of a weird function. So second derivative, I'll use 1, negative 1/4, 1 to the 3/2, negative 3/2 power plus 2. 1 raised to the negative 3/2 power is actually just 1, and then negative 1/4 plus 2. Oh yeah, that is positive. Cool. Okay, so the last thing I'm going to do is try to put all of this together to try to graph it. So I'm having to break into the, ooh, I did not know that I could do that. Okay, now I'm going to have to sort of break into the next page. So actually that's not even enough. We need a little bit more. Okay, so tying it all together, I knew the x and y intercept was at 0. I also know that there's nothing left of the x-axis because of the domain and range. And then I know that it's increasing from 0 to 0.4. So let's see, I'll put 0.4 right here. And 0.4 is an approximation, but that's the critical point. And then I also know there's a possible inflection point at 1/4, which I'm going to say is like roughly right there. I also know that it's concave down from 0 to 0.25, and then concave up until 0.4. So it should be increasing that whole time, and then it should continue to be increasing at 0.4. But there's some sort of like critical point here. So I'm trying to make my graph look like it's straight right there, because the critical point is like undefined or messed up at 0.4, where the critical point is. So the derivative has got to be a little weird. Smooth though, but weird. So I think it looks, something like that, but I don't know for sure. So I'm actually going to stop the video and then we'll graph it on Desmos and get a look at, what it looks like.